So I'll introduce myself on the next slide. I just wanted to take a minute to reflect on the title of the presentation. You might be asking yourself, Jason like a boss, like what does that even mean? Like bosses don't use JSON. Well, that's true, but let's turn to Urban Dictionary and figure out what does boss mean. So boss means incredibly awesome, miraculous, and great. That is something I feel towards JQ, but there's also a song that's called Like a Boss by Lonely Island. I'm not sure if you've ever heard it. Now, what I was really struck by how boss this individual was in this Lonely Island video. And he'll make a cameo later on in the presentation, so you'll get to meet him. But just know that this topic, JQ, is very dear to my heart. Anyone who's been around me for the last couple of years knows I like to, throw out there a cameo for JQ itself. So that leads us into what I do and how JQ has changed my life. So let's go to the next slide. It's not going to the next slide. All right. Okay, so I'm Bob. I've been working in the Freddy lab now for 4 years. Through my time at the Freddy lab, I've had to deal with many different types of processing, data pipelines, data integrations, ETLs, APIs, JSON dumps, a bunch of JSON basically. And as JSON is the lingua franca of the web, something that that I needed in my daily life was something to help me manage JSON data. So let me give you a little bit of motivation for JQ. So how many times has this happened to you? Someone has given you an API, internal probably, doesn't have any documentation, and they said, okay, it's in there, the data's in there, you just have to find it. In this case, let's just assume we want to find this gender of what is called a case. It's a concept in genomics and clinical data, so very relevant. How do we get this piece of information? All we see is a wall of text. It might go thousands of lines in either direction. So there is a solution, and that is JQ. And JQ is going to be part of your arsenal, if you invite it, to tackle many different types of problems. So let's talk about JQ and its family. So JQ is actually part of a family of tools. They weren't written by the same author, but they all share the same philosophy, and that is the Unix tools philosophy. And that's to have small programs to accomplish a particular task instead of trying to develop one large monolithic program to do a large number of tasks. Because when you do that, you end up serving really nobody because everything's watered down. So some of the tools that I've used in the past that are kind of in this family are, well, JQ, XML Startlet, very similar to JQ, although not as powerful for XML wrangling on the command line. There's PUP for HTML. It lets you do things like jQuery selectors on HTML and wrangle HTML and transform it. And YQ is kind of a close twin, I'd say, of JQ, which is for YAML. And of course, in the lineage, there's also the cousins, or some of them are actually, I would say, parents of this philosophy, and that is sed, awk, and grep, which I'm sure you've used in your daily work. So let's focus on JQ for a bit. JQ is a lightweight and flexible command line JSON processor. That's what how the author describes JQ. But I think it's not really that telling that the way to encapsulate it. I think what's more important is actually how you express yourself in JSON, JQ. So it's written in C. It has no runtime dependencies, so you can just install it and it'll work. It's actually a functional programming language. I think it's pure functional, but I don't really know if that's true. It's also Turing complete, and there is a proof in a language I'm not allowed to pronounce. And it's very terse and expressive. And it allows you to do all the nice functional operations that you may be used to from other languages. And as we'll see later, there's a lot of concepts that is borrowed from languages like Scala and ES6 and those languages as well. So you might have got a sense for how the applicability of the tool is, but these are the main use cases that I see when I use it. It's exploring JSON APIs and exploring JSON LDumps. And JSON LDumps is nothing but a new line separated, concatenated JSONs. So when you're exploring JSON APIs, one thing I've used it very frequently is with Elasticsearch, GitHub API, Docker. Docker has commands that spit out things in JSON. And for JSON LDumps, I use it to slice and dice the data, to do very, very simple command line pipelines and one-off mini ETLs and aggregations, counts, reports that you need to do from JSON metadata. And in the end, it's also just a darn handy JSON formatter. It's very convenient for that task alone. So if there's one thing you take away, it should be one of the slides I want to present on next. So these are the main entry points into the world of JQ. The first one is the homepage of JQ. It has the documentation on how to use JQ. It has the installation instructions. There's also an online interactive JQ playground. That's great for just hacking if you don't want to download it and you're saying, I don't know if I trust this guy Bob about JQ. I just want to kind of see it for myself without having to install a new binary. It's also a way to share snippets with people. And of course, there's a dedicated tag on Stack Overflow and a Freenode channel for IRC, if people still use that. It's multi-platform. All the major platforms are supported. I've only really used it on Mac and Linux, and this is how you can quickly install it, although there's tarballs you can download from the site. And now we'll get into how do you use this thing. Well, there's two main ways you can invoke JQ. One is a streaming way, and another way is reading from the file system. So typically what you end up doing is you write a curl command if you're reading from an API and you pipe it directly into JQ, or if you're just hacking on the command line, you use echo to echo into the standard in of JQ, and of course you can cat and so forth. But there's also JQ file. If you have a big JSON file, maybe it's a JSON LDump or something, you don't want to necessarily cat it or anything, you can just use the file input. There's also HTTPI-E, which I recommend as well if you want to be hacking a lot of JSON stuff, JSON endpoints on the command line. It's very useful. It adds a lot of features on top of curl. I'm not going to go through all the command line things here, but some of the things that are important are the slurp mode and the colorize and the output as raw strings. So this is just kind of a quick, handy cheat sheet if you need it, but it's also on the command line. There are two primary modes of operation. You can go line by line, which means that every line from the standard in is read and processed through the expression you supply to JQ and then output, or you can treat the whole input as a big array and it will be output through JQ as well. So these serve two different purposes. Sometimes you want to process everything at once and it's hard to do in line by line mode. So slurp mode is very convenient for that. So I'm going to kind of work through the language features, the core concepts of JQ, and then we'll go through like a realistic exercise that I've used in my daily life that some other people actually might find useful. It's in the field of bioinformatics. So the core idea in JQ is that of the filter, and the filter is very much like a bash filter or a shell filter. The idea is being able to pipe things into one another and create chains. And filters just allow you to do the basic transformation steps in a JQ expression. So let's just examine the most basic one. And this is the one that I was saying earlier. If you learn anything from this presentation, it should be this. It's the JQ dot filter. It's the identity filter. So what we have here is we have some JSON, and we're piping that JSON into JQ with the dot, and it just colorizes it by default and pretty prints it. So you get a nice indented, colorized output. Now the next one is one that actually will project out a property. Say you have an object and you want to just get the value of one of the properties in there. You can just specify dot property. So in this case, I'm just wanted to grab or pluck the X value, and it gives you 1. And it just kind of removes the outer object. So here's a pro tip. In JQ, it might kind of squawk at you if you try to do certain type of operations on things that don't make sense. So what you can do is you can add this little question mark at the end, and it won't give you an error if you try to, say, project out of an integer or something like that. And it's a way to kind of make your pipelines a little bit more resilient in a way to differing data if you're not actually anticipating it. And I use this quite a few times. It's very helpful. Of course, you can take the property access and projection to multiple levels. So here we have this nested document, X, Y, and Z, and we can project out the value Z just by chaining the path expression. This is another operation. It's useful for arrays. It's called, I call it flat map. If you're familiar with the concept of flat map, it just takes the array and unwraps it, and it gives you a set of elements. So the outer array goes away, and you end up with one element per element, basically. And you can do processing on the per element basis downstream. And I'll cover a few more complex examples of this. So the next concept is that of operators. We saw the basic filters. This operators allow you to combine different types of filters together to form more complex expressions. The first one is the pipe, and the pipe is very useful for chaining things. Just like in Linux or Unix, if you're on the command line and you want to pipe one command into another and another into another, you can do the same sort of thing with JQ. So in this case, what we're doing is we're taking the X property, so we're taking the value Y colon Z, and then we're projecting out the dot Y. This could also be done in the previous way, doing dot X dot Y, and we get Z. So very important operator. The comma. The comma is a way of producing multiple outputs. So in this case, we have this X colon 1. We can say, okay, I want the identity, but I also want the identity output. So you can see that there's 2 outputs now. So one record becomes 2. And you can do this in more interesting ways. Instead of just using dots, you can do more complex expressions on the left or right, or you can have multiple commas. Now, this one is a grouping one. So you can, again, group things together, just like in math. You can make the order of operations different, or you can encapsulate some processing in some subtree of the expression and use the resulting value as part of the output. This one's not that interesting, but you can see that I have the identity, and then I have something where I'm piping and projecting out the X. It's more of an example, pedagogical example, to show you, you can combine these operators together. And now we're getting to more arithmetic operations. So you can, say, have this array on the left, and you pipe it into JQ, and you end up doing different operations, adding 2 to it, subtracting 2 to it, multiplying by 2, dividing by 2, modulus. And so those are the 2 main building blocks. And on top of this, you can actually build new objects. So we saw just kind of streaming through some of the results and plucking out some stuff. This allows you to build new from existing. The first one is the array. This is how you build an array. You have elements flowing in for each element that flows in. By the way, I'm showing one element here just for ease, but normally each one of these would be new line separated. So you would have X colon 1, you might have X colon 2 or something, and this will apply each one of those records as it flows through. In this case, I'm saying for every element that flows through JQ, wrap it in an array. And it's very useful. You'll find yourself using this, I think, frequently. Another one is the object constructor. So in this example, I'm taking 1, piping it to JQ, and I'm saying wrap 1 around, or wrap an object around this 1 value, and then output that. And you can start to see, you can pipe these things, break it up into logical steps, reusable pieces you might use in other contexts by these primitives. Variables. These aren't really variables for the theorists on programming language. These are what they would call bindings. So it's a way of just capturing the value of an expression for reuse later. I should mention that they're usually not needed, but they help to cut down on noise in certain situations. They must start with $, and they're scoped over the expression that defines them. So if we see this basic pattern here, we have an expression as the variable. So you can take dot as $x, and then you can refer to that dot as x in the next expression or sub-expression. You can use destructuring. So this is an example of doing a multiple assignment based on something that's incoming. So this is saying, take whatever record that's incoming. It will be expected to have A, B fields, and then assign the value of the A field to X, and assign the value of Y and Z to whatever the elements of B has. And it's very similar to how this works in JavaScript. Okay, of course, now that you have these basic building blocks, what language would be complete without a nice set of functions to operate on those? I'm not going to go through all the functions, but I'm going to give you a little flavor of some of the ones that I find myself using from time to time. So it's the unit of reuse and encapsulation in JQ. They're introduced with the def keyword, can take arguments, and an important point is that the dot is an implicit argument, which means you don't have to pass it in. So it's just kind of a global variable. You can think of it as a global variable that you can always access. Very simple example is this increment. Basically, this creates a function. When you pass a value into it, whatever comes out will have 1 added to it. And on the right, this is actually a standard function, but I'm just showing the definition here. This is actually doing a mapping, which basically will make an array of the values that are passed through the function f. By the way, if there's any questions, you can stop me and ask me at any time. I'm more than willing to take questions at the end as well. So I'm going to break down just some examples based on the object type that we have in JQ. So some of the common ones you might see are length. So this would give you 4. The indices of the element 8 would be 3. Does it contain any of the values in this array too? Yes, it does. What does it look like if I reverse it? What's the minimum value? What's the maximum value? Same with strings. You can split just like you might do in JavaScript. You can test a regular expression. You can get the length of a string. You can see if it contains with the string. See if it starts with something. You can do to lowercase. And objects have a very useful set of functions as well. The one I use quite a bit is this keys. Keys is basically telling you what are the keys of an object that comes through, and it also works on arrays. So an array will give you a list of the ordinals of that array. You can delete a property, you can add, which will add all the values. You can then pivot this structure to turn it into an array of key value pairs. And you can also flatten it, which gives you the values out. Select. Now these are kind of more higher order functions where you can pass in a Boolean expression and it will only return those values that pass that Boolean expression. This one is used quite a bit. It's what some other languages might call filter, but that's an overloaded term, so I think they went with select. A very useful one that we'll touch on a bit later is the paths. So this nested document here, this nested JSON, will actually pass through paths, and then I'm providing an expression to paths to say only show me the scalars. So that will basically show me only the scalar values. I think I have a problem here. I think it should be C and D only, the last two ones. Recurse, it's so handy that they have a shortcut for it called ... Again, very useful one. How can you go through the entire substructure of a JSON document and do something for each one of those things? So the object itself, the value of A, the value of B, and all the primitives. Well, you can do this with the ... expression or recurse. The ... expression will not take any arguments, so it's just as it is. Another one, group by. Great if you're familiar with SQL. This is, or something like Lodash. This is great too. It allows you to basically group by a certain criteria. And in this case, I'm grouping by the field X. You can see how all the X's with 1 go together in an array, and the X's with 2 go together with an array. You can have modules. I'm not going to talk much about these, but modules are the way that you can break down a more complicated program into smaller bits and reuse them, share them with other people. There's actually a loader for these module system for JQ that someone wrote, and you just import the functions from the modules. Another interesting aspect of JQ is its formatters and escapers, and you can see some of the common ones here. You have text, JSON, HTML, URI, CSV, TSV, shell, and base64. If your output needs to conform to one of those specifications or environments, then you can use one of these at the very end. It's very handy for TSVs, as we'll see. Very simple example of how do you convert an array to a CSV. You pipe it through @CSV. Great for bioinformatics. Then there's a whole bunch of other language features that I just won't have time to discuss today, and that's dates, control flows like while and if, and try-catch, generators, parsers. Generators are very integral actually to JQ, but more of an advanced topic. Parsers, streaming, and some input-output functions. Now we go to the second segment of the presentation, and this is the like a boss section. And that's, of course, the guy from Lonely Island, and he is the boss. And we will see some of the useful applications of JQ, actually just one example. So let's just say someone came to you and said, create a TCGA barcode to UUID mapping in TSV format. This is actually something that I need to do quite often because of certain issues with the way TCGA submits to ICGC. So this one is kind of near and dear to my heart. It also uses the GDC API, which is a great API, by the way. But if you query the GDC API, you get something that looks like that second or third slide I had, this wall of text, especially if you add some extra stuff at the end there. So you have the same problem where, okay, I have this data, now how do I understand what it is? Of course they have great documentation, but let's just assume that they don't. The first thing you want to do is just, apply the identity operator, which just formats everything by default. You can start to see the structure a bit better now. However, it's quite big, the structure. So it might go on for thousands of lines. So one of the things that I like to do in this case is to curl it, JQify it, and then pipe it to less. And this sequence of flags will preserve the colorization that JQ does. It might be some handy snippet you could put in your bash aliases or something. So that's good, and you can page through results in less, just like you might do for a large text document. This one is actually pretty cool. It's what I call instant schema, and it's a way of figuring out the structure of a document without having its JSON schema. And what it does is it recursively goes through, prints out the paths. The paths have to be converted to string, and then it joins all the segments together, and you get something that looks like this as a result. which basically is showing you the structure. You can see you have data. It doesn't tell you if it's an array or an object, but you have hits, you have the array indice, you have the fields that are underneath there. And I look at this and it's much more immediate to me about how to actually craft JQ queries, because as you can see, the paths kind of resemble how you might express a JQ filter. So this is actually the solution to the problem. There are three types of barcodes. There's ones for cases, there's ones for specimens, there's one for samples. They call them slightly different terminology. And this is actually the solution here. It's quite a complex data structure to try to process, but this is the result. At the end, you can see I'm doing an @tsv on the result. And here's an example. Because this is so useful, you can actually save this away for something that you might want to use the next session. And so this little snippet on the top, it's basically appending it to a .jq file, and JQ will source that automatically for you every time it loads up. So I just defined a new function called schema, and if you pass that stuff into it, it's the equivalent of what we did back here. So here are some things that you don't want to do, or you can learn from my experiences about some of the pitfalls that you can fall into with JQ. There's really only a couple that will catch a newbie off guard, and that is shell quoting. So in some of the examples, I was a bit liberal with my use of quotes, but it's actually very important when you are on the command line, because the first will interpret that as multiple shell expressions or pipes. The second is the way to fix the problem, and that is to wrap things in single quotes or double quotes. I would say by default use single quotes so you don't have like a dollar trying to be replaced by a shell environmental variable. So that is a very important thing to consider when you're first starting off with JQ, and if something goes wrong, it's probably because of this. Another one, a lot of my examples started with X and Y. This one doesn't have a dot in front of it, so it thinks that it's a function, but that's not really what we wanted. We wanted the actual property. So make sure you add the dot in front of it to access the property. Another thing that you might see in a lot of different types of JSONs are dash separated field names or property names. That's a no-go in JQ, so you need to actually wrap that in what looks to be kind of like an array access. It's kind of like the associative array style of accessing something that you might see in JavaScript as well. And this one's a little edge case. It's not something I really ran into, but just be aware that you can't do this. And this is the solution, just add a pipe. Like if something doesn't work, just add a pipe, basically. That's what I've learned. So that's the basics of it, of JQ. They're kind of an overview with a little application about how you might use it in your daily life. But there's so much more to talk about in JQ world. So I'm just going to throw out some stuff here and see what sticks. So we have Java. This is a pure Java port of JQ. I've actually used this in a project because it was really handy for Quiddity. Yeah, I'm looking at you, Vincent. It's in Quiddity. It's 100% Java. It's embeddable. It works with Jackson's JSON node. And if anyone's done any JSON programming in Java, they know that Jackson is really at the core of it. And you can write functions in Java. So instead of writing a JQ function, you can write you can extend a certain interface or implement an interface, and you can actually get that code to run. So you can do interesting things like database operations or something like that inside of it. This particular example is just showing what you might see in the command line compiled into a Java object, then taking a JSON node and then applying the expression with a scope that you can define, variables and so forth, and getting a list of results, just like you would get at the command line. So this is Node.jq. This is a nice module for integrating JQ, which remember is native. It's not written in JavaScript or Node or anything like that. This allows you to integrate this in other products such as VS Code or Atom, which we'll talk about later. And it's just a wrapper around the native library. So it's more of a convenience thing. So at the moment, there is no VS Code integration or plugin, so it would be a great way to get your JQ on. This is kind of interesting, and this is what I was saying. It could be really cool for VS Code. I know a lot of people use that. There is an Atom module that runs JQ inside Atom. And you can see, maybe you can see on the bottom, there's a JQ filter that's dynamically filtering the left-hand side to give you the right-hand side. It's quite expressive and great. So there's actually quite a few other things I found just by surfing GitHub. There's a Go wrapper, there's a JQ shell, it's a JQ-based shell implementation. There's 3 Ruby implementations for JQ. There's RBQ, JQR, Junior. I don't know if it's called Junior, but I like to call it Junior. There's JQR, which is an R wrapper. There's a Lua wrapper. Then there's this collection of snippets that I found, which are quite useful. And there's also this kind of, I've meant to kind of strike through this one because it kind of puts down JQ and saying that this is more powerful than JQ, but it's basically a JavaScript-like language that apparently is more powerful than JQ, but it's really not. Then there's some other tools and stuff. JQ HTTPD, which is a server that spins up that you can fire JSON at it and it responds with JSON. I guess there's a use case for that. There's a Scala JQ parser. There's this JQ package manager, which allows you to use something like npm for JQ. So you can, I don't know if it's called JQ npm, install a particular module. There's a UI, a Mac thick client for doing some of the processing. And then this one was kind of cool. Just like I showed that schema function, there's actually a script that will generate JQ paths instead of simply the concatenated fields. So I think that's kind of interesting. So it allows you to take those and then use them into a JQ expression. And that's basically it. And all the images are by the Noun project, and these are all the things I used. Are there any questions?
So I have a question. It seems like it's a programming language, not just a command tool. But you only have that one .jq file. Like, could you build a whole application with JQ? Like, you have all these modules and all these components.
Yeah, so back on the module side, there's a way you can specify the module path, just like you do in Python or something like that. So you can have a directory that's just full of JQ files, and you can import those in your application, or even on the command line. So you could have, I don't know, something to do with a particular API maybe, and you file that away in a folder that has and then some files in there that have a JQ extension, and you can import that and use it. The .jq, if it's a file, it will source it. If it's a directory, then you can import what's inside of it. So there's a kind of convention there, but you can override it on the command line. Yeah, it is a functional. It is a language in its own right, but I'd say 90% of the time you're using it more like sed or awk or grep than you are using it like a language, because there's really no native looping in it, or because things are built on generators. It feels very much like a pipeline you might get in Linux or shell. So that's the way I've always felt it felt like to me, until I learned some of these other features which I thought were quite interesting, especially the generators and the destructuring and stuff like that. Any other questions?
How
Yes.
similar are the related ones, like the YAML and the XML?
So the question was, how similar are the related tools? I haven't played around with much of the YAML one because, I don't know, I've never really had a need to do that type of processing. I guess someone felt the necessary to create another tool for it. But they all have their own kind of dialects and flavors. I think JQ is pretty advanced. It's more, I would say, akin to awk. maybe more advanced than awk, because awk has a lot of structures and it's its own programming language. You can write programs in it, and you can also do very small snippets. So I'd say if I had to compare it to something else, it's more like awk. All right, I think that's all. Thank you.